Okay, so today we have the same question like the previous one, but here constants are like nums of I can be 10 power 9, so we can't use the brute force like yesterday. So let's go through the question again. So here we have been given nums input nums array where all the numbers are prime, and we have to and for each that prime number we have to provide a number for which x, suppose the number is x, then x or x plus 1 should be equal to the nums of I. So what we have to calculate x or x plus 1 should be equal to the prime number, and this x should be minimum. So let's take example of 7. Okay, suppose we have given a prime number 7. So what is its binary representation? 1 1 1. So if we take the minimum input for 7, and that is 3. Okay, so let's take 3. What will be 3? 3 will be 0 1 1. Or, and what will be the next number? X plus 1, which is nothing, will be 4. So 100. Now if we take all of this, we will get the 7. Now if you will check what is difference between this x and this p. Suppose there are 3 trailing ones here, 1 3. Okay, and how many trailing ones are there? There are, after trailing ones means after 0, after the last 0 how much 1 we have. So here we have 2 trailing ones, here we have 3 trailing ones. What is the difference is of 1 trailing one. Okay, because this x plus 1 is turning off the this leftmost set bit in the trailing ones. Okay, so we will use a logic like first calculating the number of trailing bits. Okay, so first, and yeah, and one more thing, if you will take any two consecutive numbers and take out the or suppose 0 0 and with 0 1, you will get how much? 1. Okay, similarly if you will take 1, okay, 0 1 or and 2, how much you will get? If both are, so you will get 3. Okay, which is binary represented nothing but the 3. So every time if we do the OR of two consecutive numbers, we will get a odd numbers. Okay, so what we know from this, so if there is a prime number 2, so that cannot have any particular x for which x or x plus 1 is equal to 2. So if we get 2, we can simply return -1, else it is possible. So now let's calculate the lane of nums. We can create an answer, return answer. Now we can simply go for p in nums. So if p is equal to 2, we can simply answer dot append -1 and continue. And if that's not the case, let's count the how many trailing ones are there in the prime number. So let's t is equal to 0. Let's create a temp variable which is equal to the prime number. T is equal to 0, temp is equal to prime. And now how to get the count of trailing ones? If we keep on doing AND operation with 1, so in that one will automatically set the rightmost to 0. Okay, so that's, and it will stop when it finds a 0. So that's why we can count the how many trailing ones are there. So simply while temp and 1, it will be true if the last bit of temp is 1, so 1 and 1 will be 1, and so it will be, and when it finds 0, it will automatically stop. So we have found 1 so we will simply t plus is equal to 1, increment the temp value, and we will right shift it temp, so that we can calculate the second rightmost one. So temp rightmost one. So now we have got how many trailing ones are there. Now we can simply see the how to get the x. Now first x, how, if you will see this example 0 1 1 and 1 which bit is gone off? See, this is 0, this is 2 power 1, this is 2 power 2. Okay, so this is 0, 2 power 1, 2 power 2, matlab this is 4. Okay, this its value is 4, so this bit has gone off, so we will simply subtract p minus. And how we can get this index from right side? So we can simply use the trailing ones -1. See how many trailing ones were there? we have counted the trailing ones for this 3 and 3 minus 1 2. So here it is 2, so see 2 power 0, 2 power 1, 2 power 2, it will give 2 power 2 4. So this how we can calculate the x value, and simply answer dot append x, and let's try to return answer and try to run the test cases. Int object is not callable. X is equal to p my, okay, we have missed the power sign here. Now let's try to run the test cases. Yeah, and I try to submit this. Yeah, so our code has passed successfully.